or my toes.
Hi guys, I hope you're having a good morning. We are going to look at graphing quadratic functions 1f today. And just like yesterday, I'm going to do problem 1 with you. Now, this method for graphing a quadratic function is actually probably the most useful. The big difference here is what we did yesterday only works with factorable functions, and in reality, most functions are not factorable. So this method should work for any quadratic function. Now it still starts the same way. We start going to find the axis of symmetry and the vertex. So let's go ahead and go through that process. Again, same thing we started with yesterday. We're going to find the axis of symmetry and the vertex. And here I do have that little formula for you. X equals negative b over 2a. So let's go ahead and identify A, B, and C. Here A is 1, B is 6, and C is 3. In that formula, x equals negative b becomes negative parentheses 6 over 2 times a. A is 1 here. You plug this in. And when I multiply negative 6 times, negative 6 gives negative 6 on the top, 2 times 1 is 2 on the bottom, and that simplifies to negative 3. So I'm going to do a couple of things here. This is the axis of symmetry, so I want to graph that. Negative 3 on our x-axis is going to be what? Right here. 1, 2, 3, so negative 3. And remember, the axis of symmetry is a vertical line. A line that goes straight up and down, and we make it dotted. It's technically not part of the graph, it's a guideline really. Now I'm going to want to find the y value for the vertex, and the way I do that is I'm going to take the original equation, y equals x squared plus 6x plus 3, and I'm going to plug in the x value I just found. So x squared becomes what? Negative 3 squared, and 6x becomes 6 times negative 3, and I still have the plus 3 at the end. Negative 3 squared is positive 9, 6 times negative 3 is negative 18, plus 3, that becomes negative 9 plus 3, which is negative 6. And so what that tells me is for my vertex is going to be the point negative 3, negative 6. A couple of you made this mistake where you plotted x and y as two separate numbers. This together makes one point. So let's go and graph that point. Negative 3, so 3 back, and then 6 down. 1, 2, 3, 4, 5, 6. Here's my vertex. Now, what we're going to do now is we're going to use that as a start point for my table. And I don't mean that that's going to be the first value on my table. That's actually going to be the center value on my table. I'm going to put negative 3, negative 6 here. And then for the remaining x values, I'm going to go backwards. So negative 4, negative 5, and then 4, negative 2, negative 1. So let's just pause and make sure we understand what we did. So far, what have we done? We found the axis of symmetry. We use that to find the vertex. And we place the vertex in the center of our table. And we found the x values 2 before it and 2 below it. So now what I'm going to do is I'm going to plug in those remaining x values and find their corresponding y values. So again, what's the equation? Y equals x squared plus 6x plus 3. If I plug negative 5 in there, I end up with negative 5 squared plus 6 times negative 5 plus 3. So you can give me y equals, negative 5 squared is positive 25. 6 times negative 5 is negative 30, plus 3. This becomes negative 5 plus 3, which is negative 2. And so that becomes my y value for here. Negative 5, negative 2. And I can plot that point right now. So let's go ahead and do that. Negative 5, negative 2 on my graph. From the origin back 1, 2, 3, 4, 5. And then down 2. And let's go ahead and find the next y value for when x is negative 4. We're going to plug in y equals negative 4 squared plus 6 times negative 4 plus 3. That simplifies to positive 16 minus 24 plus 3. Well, that becomes negative 8 plus 3, which is negative 5. So on my table then, my next value is y equals negative 5. Now, before break, when I had you do this problem, I had you plug in the other two x values to find the other two y values, but today I'm going to let you use a little bit of a shortcut. Because parabola graph is symmetric, you can say that these two numbers are both negative 5, and that these two numbers are both negative 2. And let me show you what that looks like on the graph. So I have the point negative 4, negative 5. When I graph that over here, negative 1, 2, 3, 4, negative 1, 2, 3, 4, 5. And then the reason I'm able to come up with these other two numbers is because of the axis of symmetry. Remember, the axis of symmetry says if I have points on one side, I need a matching point on the other. So over here, if I look, negative 2, negative 5, well, that ends up being this matching point right here. What about negative 1, negative 2? Well, if I go from the origin back 1, down 2, I get this point. And again, we see that they are mirror images of each other. Parabola is symmetric, so any point you have on one side, you're going to have on the other. Now, I have a lot of room left in this graph. I could plug in more numbers if I wanted to, but generally speaking, 5 points is all we want for a parabola. So we're now going to actually draw it. Remember, it should be a smooth line, curve, not a straight line, but a curve. Kind of like the root of a plant is what I would think of, like a carrot. And there we have our graph. So again, in reality, this is the better method in terms of the fact that it is useful for things that don't factor. This equation would not factor. If we had tried it, we would have gotten stuck. So this is an important method for you to know. I do want to remind you, though, you do need to be able to do both methods. All right, so that is all. Thank you, guys. I hope this was okay.